it's towards the end of the day already, so let's try to go and wrap this up so that we can go and move forward to the more interesting Q&A session later on. My name is Justin. I'm the Managing Director and founder of Silicon Ferrum Solutions, AI and robotics project execution consultancy. I have 8 years in robotics and AI sector, primarily in the drone sector. Right, I was head of business development at one of the larger drone companies in Singapore in terms of service provision for drone solutions. And as a result of my experience in providing aerial robotic solutions, a lot of my clients have asked me for adjacent competencies to be integrated into drone solutions, especially in terms of the analytics, deployment, and ground robotics components, right? So as a result of that, I've been leveraging on my experience in sourcing for these solutions, as well as delivering them for my clients to identify the best fit solutions in the market, and also understanding how client thought processes have affected the way we end up trying to implement these new solutions today. All right. So, for this particular lecture, I'll be basically using the same format as how I give my lectures for BCA. I am an adjunct lecturer at BCA for the deployment of drones and robotics and AI for construction productivity, just like how Daryl used to be an adjunct lecturer for BCA as well. So I will be talking first of all about quantifying value. How do we actually quantify the value of a robotic solution down there, right? Like right now, we've seen a lot of presentations, a lot of technologies here at this conference about the various different types of solutions down there, but it's all in isolation, right? Yeah, there's a theoretical value that is presented, but it's not necessarily reflective of the actual value it brings to our organization. And that's where I want to actually start diving into what the solution landscape looks like right now, how we're actually accelerating the confusion around the various solutions thanks to the frankly, what I call definitional abuse. So we're basically abusing the term AI to encompass a wide variety of different solutions that initially, it used to be RHAF deep learning, and now we've moved into LLMs, and now I don't know what's going on anymore, right? Then we'll talk about how CapEx and OpEx actually influence deployability and development of these robotic solutions within companies, and how this mentality that exists and this differentiation between management level versus on-the-ground operators has actually led into a lot of frictional costs and a lot of wasted efforts in terms of the deployment of these solutions. And then, okay, I guess my presentation bulked itself. I'll be talking about value capture model that discusses and presents how we are able to go and actually leverage on not just the existing AIs out there, but able to use tools to go and help us evaluate and deploy new solutions as they come on stream into the future in order to go and maximize the total amount of value we can capture from these new solutions that exist on the market. All right? So let's go talk about quantifying value. When does this solution actually start making money? One of the key things we need to understand about all these new solutions is that right at the beginning, there is always a theoretical maximal value that we achieve from our solutions. But at the same time, there's also a cost value. And the cost value is not merely the financial cost of deploying a solution. Cost ends up being just a singular compression of multiple different frictional elements that we need to consider when deploying a solution. And oftentimes, the main cost is actually not money. If everything was just money and a lot of things, you can just throw money into things, that's not enough. What really matters is the frictional cost of deployment as a result of the competencies within an organization. And oftentimes, competencies within organizations are not homogeneously distributed. In fact, what we often see is that competencies in terms of specific solutions tend to be very heavily concentrated in specific individuals or specific departments. Oftentimes, when you really drill down into things, you'll always find one young fellow who everyone presumes is actually like the digital expert, and everyone just throws everything at that one guy to go and figure out everything else. Management has got better things to do than actually try to go and figure out the finer details of getting these how to operationalize these solutions. They want to just get the results. As a result, what we end up seeing is that we see what is effectively a sinusoidal curve in terms of the total amount of value we're able to go and maximize and leverage out of a solution. When we buy a new solution, we don't actually have the value captured immediately, right? It's just there, right? Someone needs to use it in the first place. But the cost of using it in the first place, it's itself a frictional element. The people that we employ and we deploy to go and use these items need to take time off from their existing competencies, and therefore there is a cost to our organization. He's doing this new thing and not what he used to do previously. As time goes on, his costs go down, right? He's able to go and use a new competency. He's able to go and deploy it. But at the same time, as time goes on, the new technology we've developed has also started to go down in its value, not just in terms of its capital and its amortization and depreciation as a capital expenditure, but also in terms of its net utility relative to other market solutions that may be on stream at the moment. And this is where we get into a time-sensitive discussion here, because now we need to go and know at what point are we able to actually start leveraging, like letting the intersection of these two curves allow us to go and get into a positive ROI, because a positive ROI is time sensitive, right? Like we don't know when it will actually happen down there. So this is just it's a model which I just came up with. Like the values don't actually matter, right? But it means that like by the time we actually start generating quantity value of a product, it is entirely possible that like we have effectively reached the terminal value of the solution that we first purchased in the first place. That robotic solution, that AI solution, that digital solution that we bought 2, 3, 4 years ago, now is outdated. It has reached its end of usable life because now there are better solutions on the market, and now we need to go and restart the process again. We need to go and look at it again. So that's why I want to go and discuss down here. All right? Now, right now, we also must understand that AI is not the same thing, right? Like, we've engaged in definitional abuse to go and like change AI and robotics to a fairly significant degree. Last time, AI just used to mean deep learning, right? It's your standard RHEF. You go and talk about AI, you go and talk about reinforcement learning to go and actually train something to go and do one thing very, very easily. Now we're going into generative AI. Generative AI is great for coding. I use generative AI for coding, and it uses a lot of generative. It creates new work. It creates new things out of thin air. But here's the thing. In our organizations, very rarely do we actually want new information. All our organizations, all our peers have already shown here that we already generate significant amounts of data. We don't need new data. We need to capture that data, and we need to use it we need to go and translate it into the usable fashion for decision makers to go and employ it in our organization. Right? So when people say they have an AI solution on the market, speaking as a guy who's done this AI stuff for 8 years, I honestly find it frustrating that the definitions have been so nebulous that it makes people uncertain as to what the actual value proposition being advertised is. Oftentimes, the word AI is just used as a lead-in to try to go and convince a potential customer, a potential stakeholder that you are actually bleeding edge, that you actually have the latest technology, but really you're just expanding the term AI to include literally just deep data analytics. An SQL database is effectively AI by that comparison. Right? Robotics keep on having evolving capabilities, right? Like when we think robotics right now, the sexy thing to go and think about is either drones or humanoid robots down there, or for a while everyone was doing Purdue robotics. But frankly, robotics just means an automation process, right? In a built environment, robots have never been particularly well used because built environment is an open context environment. An open context environment means that we can't actually control the variables that actually happen within our work site to the degree that we can in, say, a factory. That's why in a factory robotics are always, here's something at a fixed location. I got a conveyor built, it brings my tools and my products and my materials over to that robot does things effectively down there. Humanoid robotics now are really evolving. Like whenever I used to go and give these types of presentations, or when I talk to senior people, they always ask me, can I use humanoid robotics or whatever? And I'll say you'll never be able to do it, at least within the current time frame. But now we've been seeing an evolution. Humanoid robotics, especially within an open context environment, are starting to evolve to a point where they may be deployable within an 8 to 12-month period. Whether they're necessarily better than the existing human solutions, as in actual human solutions, that's a different question. But at least now, the humanoid robotics are being able to be optimized enough to operate in this dynamic environment where previously you couldn't employ any robotic solutions at all. Try getting a robot to go and walk up a slope that's muddy and that has got inconsistent patches of grass and ground covering down there. A human being could have adapted and be able to go and control his fall. You know, he falls down, he gets back up. Robot falls down, most of them can't get back up. Right? So this brings me into the main point I want to go and raise up, which is about how we conceptualize the value of these solutions that we want to bring to our organizations, right? So we're going to think about it in terms of capital expenditure versus operating expenditure. A lot of organizations like to go and, when they do in-house R&D, we always go and put it under a CapEx, right? And CapEx is very easy to go and finance for organizational purposes because it means that your financing options are normally a lot easier to go and obtain. You know, you're able to go and leverage on effectively the total market value of your company, especially if you're a large organization with a significant flow. OpEx is normally a lot more irritating for people to go and quantify because OpEx comes in on your daily expenditure, right? Like you need to go and take it out of your pocket every day. But the reality is that CapEx actually is a cost as well. Sure, HQ is the one that pays up for it, but then like you'll be down there on the ground, you don't actually bother, you don't actually need to think about this robotic solution or AI solution or software that you've deployed until about 5 years later when suddenly there's an accounting reconciliation and then the company and the management at the top says, okay, we need to take an impairment, now your bonus is affected, and then you're just at the ground wondering, what did I do wrong? No one did anything wrong. It's just that is that a lot of people on the ground don't necessarily employ the full value of their solutions because it is treated as a capability that is developed and resident at an organizational level and not necessarily deployed at a project level to go and actually capture the value down there, right? So one of the key problems is that at least in my experience, I don't know about the rest of you guys, but in my experience, a lot of the time, these fancy new solutions that get onboarded, they either get resident and like they stay in like a lab somewhere or in some test case scenario, and they get used for what I call it a clap hands exercise, right? The sort of thing that you go and bring an investor or a shareholder or senior manager to go and come in to show how innovative you are. And then after that, when it comes to your actual deployment of your solution, you go and get a guy to go and come over with a paintbrush to go and like redo the painting of your walls. That's an unfortunate reality of all of these solutions, all right? Now the thing is, why is it that we end up in that case? We end up in that case because by conceptualizing new solutions as a CapEx, rather than an OpEx exercise, there is no end user incentive to actually maximize the value of the solution being presented. And why is there no incentive to go and operationalize these solutions, even though it's been promulgated downwards from management, right? A lot of it is because of implementation time costs. Barriers to technology adoption are rarely financial in nature. It does not matter to the forklift operator whether you're giving him a $10 million forklift or a $30,000 forklift to go and operate. He just wants the forklift to work. Similarly, the time cost is about whether or not the solution works for the end user who is actually using the tool in the first place. Whenever I'm using these new solutions, right, whenever you have these solutions proliferating, look at what Autodesk website advertises for the AI solution. I have no idea what they're talking about down here. Sorry guys, Autodesk, I know you're out there. But you look at these things, they all sound like marketing fluff. And that's because to actually leverage, a lot of it is definitional abuse. You're just changing an existing tool and calling it AI in order to go and capture the thermostatic moment. But we're also not really understanding the net value of these capabilities because it is just so difficult to understand. A boss, a manager, doesn't want to go and understand these things because he has better things to do. He's got people to manage. And when you have people to manage, what do? You get a person underneath you to actually do the understanding for you. And that poor guy gets overloaded. Subject matter expertise is already difficult enough when it is for an individual operation. When you start proliferating cross-subject matter expertise, we run the significant risk that we are overloading these individuals in their ability to deliver, to understand and therefore deliver on the results. And then it becomes an issue of whether or not the capability advertised matched up to his marketing literature, or was there a competency issue that was not identified in advance because of this mismatch in capabilities and requirements that is not adequately communicated by these new solutions that have been proliferated in the market right now. All right. So the other barrier to competency, the barrier to technology adoption is limited internal knowledge diffusion, right? There are all sorts of nice talks about how you're going to have a new human-centric, we're going to have like humans learning everything down there, core digital competencies. I don't know about you guys, I'm lazy, all right? I don't want to learn everything under the sun, right? I want to go and ask a question and go and get an AI to go and get me the thing, right? Most of my clients I work with, whenever they want something out of me, they never want to log into any platform I want. Teaching them how to log into a platform can be itself, a 5-page PDF that I need to go and churn out for them. What they want is just the end result. And this means that managers, senior managers, other stakeholders in an organization rarely want to actually be the resident subject matter experts in using these new solutions. There is no knowledge diffusion because it is not core to the operation. Some things we are forced to learn. We are forced to learn how to use Outlook. We are forced to learn how to use Microsoft Word, Excel. These are the most common things. CAD, for all the fellas down here who are doing Archie stuff. But no one wants to actually learn how to use BIM because selecting a BIM model and rotating it around is more difficult than playing a computer game. And those things aren't simple at all. So organizational division of labor has been a foundational concept in modern organizations and in modern management theory. It's a great way to go and divide labor, but it also means that a lot of employees, internal stakeholders, employ the path of least resistance, right, in order to actually get their work done. I don't want to learn how to use this new tool. I'm going to get Justin, that smart guy over there, and he's going to go and get me the results I want. I'm going to WhatsApp him and ask him, can you get this for me? And Justin, because he is the only smart guy who knows how to do this, will find it easier to go and do it himself rather than teach you how to learn to do this. There is limited knowledge diffusion within an organization as a result of the capabilities and complexities of these new tools being so opaque to begin with. Right? So I'm going to go and go against the grain and present a negative example as to what happens with a lot of these technology adoptions in reality. I call it a cycle of failure. Right? It always starts optimistically. Organization brings in a new capability. We want to maintain that we're right on top of the game. We've got the newest, greatest technology. Right? The next step, unfortunately, right, is that internal resistance occurs. And internal resistance occurs not because of obstinacy, it occurs because of frictional costs, especially the frictional costs in technical competency in being able to even understand, much less understand how to use, much less how to deploy the advertised solutions that are being developed internally or being brought in from external sources via OpEx exercise, right? And then we fall into a downward spiral. Here's the advertised solution. It's not going very well. We invest less resources into trying to go and deploy within our organization because the guy that we've tasked to actually learn how to do this is not doing a very good job about it. And in the end, the technical concurrency of our capability lies fallow. We have invested X dollars to get a theoretical output of Y. In the end, we're getting a fraction of Y, even though we spent X. Therefore, we need to go and invest into a new solution again in order to go and recoup our investment and make sure that we're on top of our game, and the cycle begins anew. So, one of the examples about this is the great proliferation of like various BIM viewing softwares, right? Again, apologies to all the fellas who have their presentations and their booths out there. They all look really great, right? But there's a fairly common comic that I've seen a lot that talks about how you start with, like, people will say, oh, why do we have so many different power plugs, right? We should just have one universal power plug, and now you have like 7 different power plugs as opposed to 6 different power plugs, all right? A source-agnostic BIM viewer is an example about how new capabilities require new expertise and how to go and even use it in the first place, all right? And then that capability utilization gets restricted back to the expert users who know how to use it. And management does not care. Management just wants the PDF reports in the end. Everybody wants to just work from a simple thing, right? So how do we actually break this cycle of deployment, right? We're running out of time, so I'm going to speed this. How do we break the cycle, right? One of the key things to go and do that is to go and think about AI not necessarily as a tool unto itself, but a tool that allows to go and facilitate the integration and deployment of all these other solutions that exist in the market that are coming on stream as well, right? Different capability horizons exist, right? And different deployment horizons are resonant in the ecosystem that allow us to go and figure out what's the time frame that we have to go and actually use an AI to go and integrate into our system and therefore use all the tools we have available in our organizations, all right? As you can see down here, one of the key things to see is that actually supply chain and inventory management, I guess, like, is the closest approximation for what constitutes construction down here. The deployment horizon, manufacturing actually is probably a little bit closer. Right? So you can see that manufacturing and supply chain actually have got the longest deployment horizons, technically speaking, as per this McKinsey report. Accurate or not, I don't know. I use McKinsey because I just got McKinsey to go and act as my primary source of information. Anything wrong, go blame them. Right? So we need to go and figure out, not just how to go and like not just how to go and cost a new solution, but how quickly can we develop a new solution and onboard it for our internal purposes, all right? So AI solutions that can exist, we should have a sea change in our thought processes, not necessarily because our thought processes are wrong, but it's because like things are evolving so quickly right now that the previous models of how fast technology can be integrated and deployed must now be updated to go and reflect the sheer speed of change available, both in terms of the tools available that we can deploy, as well as like the speed of like new solutions that are being developed by other smart people out there in the market, right? So one of the other ways to go and think about it in a value capture curve, as I mentioned earlier, is to go and do the cost compression. Right? So under a cost compression model, we're basically trying to go and like see if we can incorporate amortization scheduling directly into the capex expected value, right? In order to go and give ourselves a cost scheduling factor, and then like use our total, and then like from that point forward, we need to go and like see if we can switch out, we can go and reduce our time to go and switch between new solutions. So as opposed to having a long deployment curve, we try to go and actually like increase the speed by which we can actually develop the core competencies within our organization. By developing these competencies within the organization and not restricting them to a single point of failure, meaning a single poor overworked guy, we are able to go and actually maximize the value of these new solutions as quickly as possible, right? Under this type of theoretical model, your total cumulative value for onboarding new solutions becomes a lot higher, right? Like I had a value, I can't remember the first value, but it's effectively double down there, right? If you're able to go and like just change the value of like how quickly you can like onboard a new solution. So speed really matters in deploying a new solution, right? But the other solution is just simply reducing the cost in the first place, right? As opposed to trying to be faster about things, we can try to decrease our internal cost, our internal organizational cost, and therefore an internal major frictional cost, and try to go and onboard a new solution at all, right? And theoretically, this can lead to a significantly higher onboarding process. Now, how are we able to actually perform this type of solution, right? Obviously, you know, I'm here talking about AI and robotics. I'm going to go and advertise that AI solutions can exist for that, right? Primarily in the form of like customized agentic AIs down there, but I don't want to advertise that this is a ready solution yet, right? The ecosystem is simply not set up to go and allow AI to AI communications, especially in being able to go and easily summarize it for the usage of management level decision making yet, right? That is theoretically one of the models that will end up going. Now, everybody down here is saying that you can talk to my AI, and my AI will answer stuff for you, but we don't want our AI to answer a question or how to use it. I want my AI, when I go to a software platform, I want that AI to just deliver me the thing I want. Give me project status, give me manpower status, how many added manpower have I had for the past 4 months. I don't want to log in to have to go and like navigate and look through the entire system. I just want a result. Internal AI execution agents, right, are able to go and assist in smoothing this process. Overcoming the frictional costs of solution deployment is the most important step. And why is that the most important step? Because if you can overcome the frictional cost of deploying new solutions, especially at an organizational level, then you can actually integrate new solutions quickly as well and maintain capability concurrency. But this is why CapEx versus OpEx matters. Because when we talk about CapEx always has a long development timeline, and we are actually upfronting the cost down there. When we move into an OpEx mentality, we're able to just buy from whichever smart fella out there has got a better solution, right? Given how many smart people are out there desperate trying to go and sell their solution, there are plenty of people out there with good solutions that you can just onboard and go and repeat the cycle over and over again, especially as time goes on, right? So we talk about the total delta capture, right? Which is the cumulative value of like how much value you can extract by being either faster in learning how to use your new solutions, or by reducing your internal costs as a whole and try to go and deploy your new solutions, right? Controlling your internal cost structures, financial, obviously, as mentioned, but also in terms of your frictional costs, your manpower and institutional knowledge retasking costs can lead to very significant value capture when it comes to integrating and deploying new solutions down there. Plenty of smart people, plenty of new solutions available. We can reduce that cost internally. We're able to go and really maximize the unlocked value for organizations, right? So the main thing is that we must be also aware of what the technical currency of all the available solutions is, right? Value maximization is not just here's a new solution, let's just bring it in. It's about knowing what our own organizations really need, what the current market offerings out there are, and what are our limitations that prevent us from even onboarding this in the first place. By being able to go and quantify, or at least have an approximation of quantifying the costings, right, of how to go and deploy these things, we are able to then come up with a proper scheduling as to at what point we should then start looking at bringing in new solutions after that, right? So in order to go and future-proof any digital solution, AI, robotics, right? We must go and consider one of the main things which is used in decision making, which is the OODA loop: observe, orient, detect, and act, right? Decide and act, right? So new capabilities must be plugged in within the OODA loop, right? In order for management level decisions to understand where we can offload the institutional costing, meaning the frictional costs that we burden onto like specific subject matter experts, and allow that to go and like move forward. Okay, So future footprint capability awareness, some robots suck, don't buy into the hype yet. All right, we need to go and move on now. Key takeaways, right, significant opportunities do exist. We have significant barriers to adoption within our own organizations, and strategies for success should really talk about trying to go and quantify the value capture and reducing where our own internal frictional costs exist in order to go and actually capture the value of these new solutions that exist. Because the new solutions may not be the best in class if it takes me too long to even deploy it in the first place. All right, thank you very much.